To make a basic attack smear, the first thing we're going to want to do is open Material Maker to a new material, and then for making textures in general, or if you just want a texture, or specifically for making textures for Roblox, you don't really care about this. This is the export node, you don't really care about it, so you can just either throw it off to the side and not care, but you could also just change it to this because it's a lot smaller, and then just ignore it, go to somewhere else in the node graph. The first thing we want for an attack smear is a ring, because a attack smear is sort of like a circle shape, but it's cut off. So to make a ring, the simplest way that I know of to make a ring is kind of a neat trick. So you start with a circle, and I bring the radius up to 1, and then bring the edge width up to 1, and you can notice that the edge width is basically what percentage of the circle you've defined is solid white. It's sort of like the interpolation between white and black, and you bring that all the way up to 1, so you basically, what you have here is a perfectly smooth circular transition from white to black. And then you're going to map it into a range filter. And by the way, you can click and drag out of any node to immediately open this menu. And you see that so basically what range does is it captures, I'm not sure what the width actually means, but you can fiddle with the controls, but basically it captures values around a certain value. So if this is white in the center and black at the edge, then the lower you go, it's capturing lower values, and then at the higher you go, it's capturing higher values. So with a perfectly, ramped circle like this, you get the ring, or you get values in the center to the edge. This is sort of a clever way of doing a ring. And you can change the width of it, and contrast will kind of affect the ramping up of this. So if you do full contrast, you get perfect circle, and if you do zero contrast, you get another perfect ramp. So we're going to want something decently large. And if one of the problems with this approach is that if your width is bigger than so like, this is hard to sort of explain, but if your value minus your width, and again, I'm not sure how the width scales, but if the bottom value minus the width is lower than 0, then you start capturing the black. But you can fix that pretty easily by raising the value and then the width. Just make sure you don't do that, basically. And I'm gonna leave the contrast at maybe like something like this. So we have solid color and then sort of smooth ramps down. So this ring will become part of our smear, but we kind of want to cut it off because we only want like this. We only want like maybe a how many degrees would that be? Like a 210 degree arc of this, basically. So we'll go to so let's create a new gradient, and we're going to use the circular gradient. And the circular gradient looks like this, and I think you can already see where I'm going with this, perhaps. But what you can do is you can blend these, and what I'm going to use the multiply blend mode and change the opacity to 1. So basically what multiply blend does is it just takes the background and the layer 1 and it multiplies them together. And you can see that this darkness is being applied to the ring, and it's creating this effect. Another way you can do this, and actually this is my preferred way just because there's less clicking, is you can use a math node and change it to multiply. And so what math does is it takes two grayscale, images, and just multiplies the grayscale value. So you can think of this image as just a matrix of values from 0 to 1. And in fact, you probably should think about this image as a matrix with values of 0 to 1, where 1 is white and black is 0. And then same thing here. And what math does is it multiplies every pixel in the image with it runs the operation that you ask for, in this case multiply, on every pixel in the image. So in this case, you're taking this ring and you're multiplying it by this, and because this is all black, it all ends up black in the end. And because this is black but it's gray and gets higher and higher, it ends up sort of blending these things together. And then what we can do is this obviously is too much of an arc. It's bigger than we want it to be. So what we can do is you can drag the gradient up, and you can see what's happening here on the source image. You can move the gradient as it up, and I'm looking for something like maybe 210 degrees, and there we have a much smoother arc there. This cutoff here is a bit annoying, and I would prefer it not to happen. So what we can do is we drag this in, and if you double click below the gradient, like in this black space down here, you add a new control point. And if you double click the control point, it'll open up the color. And I want this to be black again. So now you can see that it goes from this black to, and then it comes up to white, and then it goes back down to black. And you have that effect there, and you can sort of move it around. One thing that I don't like about this approach is that you can sort of see this really noticeable white highlight here. I don't know if it's clear to you, but it's clear to me. And one easy way to fix that is to change the curve on the gradient. So by default, this is linear as far as I know. This is constant, and you can see what constant does. I believe this is, I don't know if that's power or cosine. They're just shapes. I guess the software doesn't expect you to care about the math that much, but if you switch this from linear to something smoother, like this function or this function, I prefer this one because I do actually want it to be more dark, then you get a much better result, and that highlight is not nearly as noticeable anymore, which I prefer. So we are a good way in, but this is like very bland, so we kind of want to give this some texture. So I'm going to go up here and make a new node, make a FBM noise, and the first thing you should do when you make a noise, I would recommend pretty much always using FBM noise. It's pretty much a universal. There are cases where you'd want to use different ones, but one sort of gotcha about FBM noise is it always starts with the same seed, so you should click this dice a few times to change it. And we'll leave these settings alone for now, and we'll drag this into a node called a circle map. And what circle map does is it basically twists something around a circle. And it looks pretty okay for now, but it's not exactly like a great texture. It looks a little swoopy, but it doesn't really give me the feeling of velocity that I'm looking for. So what we can do is change the scale Y and maybe lower the scale X. No, let's keep the scale X. We can raise the scale Y and we get much more like swoopy. I don't know what the technical word for that is, but like it feels quote unquote faster to me. And what we can do is take this and we can multiply this with the work we have from earlier. Again, you could use the blend node with multiply mode if you want, but I don't know, I prefer math. I'm a much more math oriented person, and then there we go. So we've given this, so we constructed this texture and we have given it this, like we've made it look more swoopy, I guess, for lack of a better word. And yeah, I mean, like this is kind of exactly what I'm looking for. Could mess with this to give the highlight, to put the highlight more up front. If you wanted, what you could do is maybe you want the smear to be a bit longer. You might want the highlight to be like perfectly aligned. So like the brightest spot is right here, and you might want that to be perfectly aligned with, say, the right edge or the top edge. So what you can do is drag out the end and put it in a transform node, and then rotate it so that maybe the brightest spot is facing straight up. And this is one you're just gonna have to eyeball, which is fine. I mean, we're making art after all. It's all about eyeballs. So yeah, I'm gonna have the smear pointing straight up, and then I'm going to, the final step is to colorize it. And I believe, yeah, so colorize is right here, but you can also type it out. And this basically maps from black to white. It maps it to different colors, so you could make this, you know, red if you wanted. But for the most part, I prefer my textures to be white, because then you can multiply them by any other number in Engine. So I'm going to change this to white and then drop the alpha down to 0. And then you get the texture plain as day there. So one thing I'm noticing is this texture is actually a little dim. It's not as, I guess, bright as it could be. And there are a couple ways to go about fixing this. Basically, I want the brightest point in this picture, I want it to be full white, and the darkest point in this picture, I want it to be full black, and obviously that's already true. But I like the maximum value of this whole image is probably not white. It's like some gray lower than 1.0. So one way to fix this is, and I don't like this one as much, is you can use auto tones. And what that does is it will automatically find like the maximum value and bring it up. And the reason I don't like this is because this is a buffered operation, and it's nothing like inherently wrong with buffered, but it does make some other more advanced techniques more difficult to use. And you can get like very similar results from just using map yourself. So type map and then you want this one. So tones map. And basically what this does is it takes an input min and max and an output min and max. And so like values of 0 from the original image will output to values of 0, and values of 1 in the original image will value to 1 in the output. So to brighten the image, you can just pull the input max down, and you can see that the image is getting brighter. And so when you're going too far, you'll notice that it sort of clips, quote unquote. It starts clipping, like you see that this blob of perfect white is starting to grow and grow and grow and grow and grow until it consumes the whole image. And basically you can just eyeball it, and once that highlight starts showing up, you just stop. And that now I have like a very similar result to auto tones, but it's not buffered. And again, you might not understand what that buffers are. Buffers aren't bad, they're just they make certain things more difficult, so avoiding them is nicer. So now what we can do is we can drag this into colorize instead, and the smear is much higher, a much better highlight. And it's kind of hard to see the texture here because of the background, but it's just this, except black is now transparent. So to output this, we are going to export. If you're using Roblox, you'll want to be probably mindful of how much memory your textures are taking, specifically if your game wants to work on mobile. And so I would recommend definitely be very sparing with anything at like 1024. 512 is also pushing it. 256 is okay, but you'd be surprised that you can get just fine results with 128 by 128. And we'll call this basic smear 1.png. So now we've made the material. I will take, so if this is all you're interested in, that's the end of the video for you. However, if you're interested in seeing how this could be implemented into Roblox, then keep watching. So we're going to start by importing a rig. I like to use the Mesh Avatar 2016 R15 just because, I don't know, it's kind of generic. And the next thing that we're going to do is put a particle emitter inside of this character. And there's a couple of gotchas here because Roblox is a quirky engine, as everyone who uses it knows. But let's add a new attachment to the humanoid root part, for example. And we'll call it emitter attachment or something like that. And we will add a particle emitter to that emitter attachment. And as you can see, it's using this default like star texture. We can copy the basic smear in that we uploaded earlier. And now it's that texture instead. Smears don't last very long. Let's give it like a lifetime of 0.2, and we can drop the rate down to like 4 a second so that we're only seeing one at a time. As you can see, we're only seeing one at a time. Let's increase the size maybe to like 6, maybe 4. Yeah, that's pretty reasonable. Obviously, we don't want it to just float upwards. And we also don't want it to, we want it to have like an actual orientation in the world. So we're going to change the orientation to velocity perpendicular. So that is nice. We're going to change the speed to like 0.0. It can't be 0 because then it doesn't have any velocity to calculate as perpendicular, but you can give it like a really small number, and you won't even be able to tell that it's moving. So here's where one of the weird gotchas and why I used a new attachment instead of making a root attachment is if you, at this point, the particle has no rotation, right? And that's what we want. But if you change this to have locked apart, suddenly it will start rotating. And I think this is because the attachment is pointing straight up. Because the attachment is pointing straight up, the math is probably assuming that, like, you know, there has to be some math done to make sure that the particle is quote unquote facing up. But if it's already going perfectly straight up, then the computer just kind of gives up and doesn't know what to do. So, as annoying as this is, one of the easiest ways to fix this is to just rotate it by like 1 degree on the x-axis. And now we have, or well, yeah, it doesn't really matter. It could be negative, yeah, maybe like 1 degree. And you'll notice now, which is really nice, is that the orientation that we had before is, well, it's mirrored horizontally, but this is the part that's going to take the most fiddling, probably. But now it is sort of in place, and it will move with our character, which is what we want. So now we can change the rotation. So we probably want the smear to like start over here and come around. So like imagine that this character is making a punch motion, right, from right to left. So let's find a good starting point by moving the rotation. So like right here, perhaps. Yeah, let's go with 90. Why not? And then the rotation speed is going to be, we probably want it to rotate like 180 degrees, but in its lifetime. So what you can actually do is you can, in some of these property windows, not all of them, weirdly enough, but in some of these property windows, in particular this one, you can actually do math. So I just did 180.02 seconds, and or per 0.2 seconds, and lifetime is 0.2 seconds. So now it'll do that. One thing that's kind of annoying is that rotation speed also affects where the particle starts. So you notice that it's sort of starting over here instead of over here where we had it. So like I said, you'll just have to adjust. So that is more what we're looking for right here. Yeah, that's perfect. So you can imagine this character sort of punching from right to left. His right to his left. Now we want to give it like some transparency, a timeline. So like it should start and finish fully transparent, and then we'll add in a couple of things. So we'll pull the difference is slight, but I think it's noticeable. And that looks pretty good. So now we have this attack smear that we could use for a punch. I won't go in so far as to like start scripting, but what you would probably do is leave this disabled, and then when you punch in a script, you would do something like workspace.rig.humanoid root part dot emitter attachment dot particle emitter emit 1, and then every time you punch you'd do something like this. But yeah, that's basically how I would do a smear, a basic attack smear. Thanks for watching.